Hey guys, welcome again to the Maths Club. We are starting another brand new concept in line with the WAEC syllabus. So we just finished the concept on sequence and series, and now we are in set theory. As always, we're going to start some introduction, examples, and then we will solve the WAEC past question from the last 10 years, which is 2014 to 2023. Without further ado, let's get started. So what is a set? A set is a collection of well-defined objects. I mean, this is a bit of English, but let's look at the picture to depict what we're actually saying. The first thing that comes to mind when any student sees sets is mass sets, right? Why is it called mass sets? Because it's just a group of well-defined objects. I mean, for you to do any construction, you need a ruler, you need eraser, you need a sharpener, right? So you need a protractor, you need set squares, and you need compass. So all things that you need for your construction, right? They grouped all of them together and then they put it inside this metallic body, right? And it's called a mathematical set. Another example is, so you have a plate of fruits. This contains different fruits of different types, and you just put them together inside a particular plate. That is a set, right? Just like when you're serving food in your house, right? You take a plate dish for your parents, a dish for your siblings. Everybody has like individual foods, so that combination of all of them is basically a set. So how do you represent the sets? In mathematics, sets are represented with curly brackets. So you see these curly brackets, these opening curly brackets, these closing curly brackets. When you see this, you know they are talking about a set. So this is an example, right? A set of fruits, basically. So you see the apple, the banana, a bigger apple, and probably this is guava or something, right? And you can see all of them are inside a curly bracket. Elements of a set. The members of a set are called elements, right? So all those protractor and all those things like the apple that we saw in the previous example are actually called elements. You don't call them any other thing, but in terms of sets, you call them elements. So look at this now. So I mean, if this was a set of maybe different things, I don't know, this is scissors, this is crayon, this looks like glue, right? And this is like paper. Like maybe you want to do a project in your secondary school. So each item is called an element. Consider this an element. This is element 1, element 2, element 3, element 4. Now if you want to find the number of elements in a set, right, you can do that by counting, or also we also represent them in a particular way, right? We don't just say, oh, the number of fruits in this plate is 5. No, you don't just say that. We represent it by saying, if we want to find the elements in a set A, right, we represent as n of A. You can say n stands for number of elements in the set A. So if this was a set, right, I know that we don't have the curly brackets, but what do you think would be the n of A? Great. So let's count it together. So this is 1, 2, 3, 4, 5, 6, 7, right? So 7 items inside this mass set. So if this was set of A, our n of A will be equal to 7. Luckily, this person has not borrowed anybody's eraser or ruler or this thing, because mass set is one of the things I used to misplace the most. So we'll talk about universal sets. Universal. When we say the universe contains everything, planets and everything. So what do you think the universal sets would be? So in set theory, universal sets is a set which contains all objects, including itself, without any repetition. So I mean, when you have a set of everything without repetition, it's called a universal set. So if you wanted to find the set of all fruits, right, you say apple, carrot, and all those things, but you cannot repeat. You cannot say apple, apple. No, each object is meant to appear just once. So how do we denote it? We denote it with this u, right? This u, or with the epsilon. This e is called epsilon, right? So whenever you see this u, and so you see u is equal to curly bracket, you know that is talking about the universal sets, right? So you see epsilon is equal to curly bracket, something, you know that's talking about the universal sets. Now look at this example. I know this Venn diagram. Let's just take it as an example. So this is set A, right? Forget that there is something joining. We'll look at that later on. This is set B. So the universal set you can see is everything. It would be 1, 3, 5, 7, 9, 6, 11, 13, 15. So all the numbers inside this rectangle is a member of the universal set. Now, what is a subset? In mathematics, a set A is a subset of a set B if all elements of A are also elements of B. Let's say this circle, this big circle outside, is our set B, and then this sphere, it looks spherical, I don't know, right, is our set A. Do you agree with me that in this set B, everything that is in set A, which is this smaller guy, is inside set B? Yes. So when all the elements of a set can be found in another bigger set, then we say that that smaller set is a subset of the bigger set. So in this case here, if I bring it back and I go back to this place, you can see that in the universal sets we have everything 1, 3, 5, 6, 7, 9, 11, 13, 15. In set A, which is this small circle, right, this circle here, we have 1, 3, 5. You agree that if I list out everything in the universal sets and I list out everything in set A, everything that is in set A would be inside the universal set. Universal sets contain more, but I'll be able to find all the elements of set A inside the universal set. So that means that set A is a subset of the universal sets, and also same thing so for set B. Set B also will be a subset of the universal sets. So coming back to our example, polygons are a plane shape with straight sides. So when you saw this plane shape with straight sides, this side, one side, two side, three side, four, right? So these are all the polygons. But among the polygons, there are some shapes that are called regular polygons. What do we mean by regular polygons? Regular polygons are those polygons with the same sides, right? So you can see like the length of this side, length of this side, length of this side, length of this side, and that is a square. Also, you can see, and in the square, the inside angles are 90 degrees, 90 degrees, 90 degrees, 90 degrees, right? Same thing so for this equilateral triangle and then for this pentagon. So a regular polygon is the polygon whose sides are the same and all the interior angles are equal. So among all these polygons, so you can see other types of triangles. So in this set of polygons, you agree with me that this one here, this regular polygon, is a subset of all the polygons, because then by the time they list out all the polygons and list out all the regular polygons, you find all the regular polygons inside this polygon. So this is a classic example of a subset. And what is the importance of sets? The first one that it us is that set helps us to organize and categorize data. In your kitchen, there's a place where you keep spoons, there's a place where you keep cups, there's a place where you keep foodstuff, right? So all of all those things, you are putting them inside sets. And you will see sometimes, and it's for some households, they have this cutlery set. You see the knives, the spoons, the forks, and all those things all together, right? So you can see that set gives a lot of organization and categorization of data. So it's also useful in mathematics, in computer science, and statistics. Because if we're dealing with statistics, we need to group them like, oh, we want to know the number of people in the whole universe, right? We need to know, okay, in the continent of Africa, in the continent of Europe, right? Or even in Africa, how many girls are there, how many boys are there? So we're dealing with sets. You can see that this is a very, very useful phenomenon to understand. And it sets the foundation for more advanced concepts. So as you grow in this thing, you'll be seeing more advanced concepts that build on sets. So that's basically it about sets, like the introduction to sets. In the next video, we'll be looking at the types of sets that we have in mathematics. See you there.